Welcome back. We're up to Lesson 7, Investigating Faults. In this lesson, students will use a fault lab to investigate the movement of tectonic plates and particularly the effects of friction on the intensity of earthquakes. It's pretty straightforward. You can follow along with your book and your PowerPoint, especially when it comes to our added notes and questioning that'll keep you focused on the 3 dimensions. But I do want to give you some tips about Inquiry 7.1. You will need to set this up ahead of time, and the directions are in your teacher's edition at the beginning of the lesson, and it's pretty clear. You will want to play around with this a bit yourself before you pass it out to your students. And one thing to note, you will have some extra Velcro strips. You need to keep those handy because they do have a tendency to come off during this inquiry. When you reach this inquiry, can follow the procedure in the book. The first thing that it asks students to do is to experiment a little bit by pulling on that unfixed block after putting a piece of masking tape over the fault. And this may be something that you might skip over if you're not paying attention, so you do want to be sure to do that because students will notice when they pull very gently on the unfixed block, the masking tape wrinkles and it looks a lot like this example of creep. So it's pretty powerful. After that, students will begin to explore the effects of friction on the amount of force that it takes to cause an earthquake to happen. So it asks you to tape your blocks together instead of little houses, which you have centimeter cubes to represent your houses for effect. And students will investigate the effects of 1 piece of Velcro, 2 pieces of Velcro, and 3 pieces of Velcro. And they'll pull on the string with the spring scale, and it is a little bit, you have to keep a close eye on it because what will happen is this, in some cases, it will slide slowly. So students are watching that spring scale, and you want to have them read the maximum number of newtons that the spring scale reads. But sometimes when they're pulling on it, it will slip. It'll be sort of a sudden earthquake. So they really have to keep an eye on the spring scale. And also, be sure to have students wear, and you wear also, your safety goggles because the little centimeter cubes will tend to fly around the classroom during the simulated earthquakes. So this is a good experiment where students get to change a variable, which is the amount of Velcro representing the friction in the faults. And they'll need to do several trials and take averages and compare. So it's a good chance for students to go through the scientific inquiry method and use some mathematics. And we've added a elaborate activity at the end where students really have to use their critical and creative thinking skills to come up with all kinds of ways to talk about an earthquake. And again, there's more information about this in your notes. Your overarching thought in this lesson is that the more friction that exists between these plates, the stronger and more devastating the earthquake can be. If the plates are worn down and smooth, then the energy doesn't build up between those tectonic plates, and so you don't get these strong earthquakes. So again, enjoy that lesson. Students enjoy it a lot, and I do notice that I say that every time. And we'll see you back for Lesson 8.